And show the right thing this time. Maybe this time? There we go. Okay. Sorry for that delay. Going over first the syllabus. Everybody except for Colby has the syllabus and a form. You want to come up, Colby? I'll just grab these two things. Okay, so first I'm just going to go over some highlights of the syllabus. So the top we have just the basic information about when class meets and whatnot. Important things to note are, for instance, where my office is. Right across the hall. You go out that door and go into the office. It's across from it. My office hours are posted right here. If I'm in my office, come on, don't say, oh, it's not office hours. Because helping students is a lot more fun, and I think more a part of my job than doing paperwork, grading, preparing learners, that kind of thing. So feel free to come in, if you have questions, and I'm in there. These are times when I should be there, unless something comes up, like, we have a visitor from Loma Linda and we have a meeting with them or something like that. We have class every Monday, Wednesday, and Friday at 9:30, right here. You made it here, so obviously you know where we are. And we will have lab, this self-same room, at 2:30 p.m. on Mondays starting today. So I don't know when these were available in the bookstore, but they certainly should be now since I have my copies now. So this is our lab guide, and you'll need one before lab today. Hey, look, it's snowing. You'll need one before lab today because it's basically a fill-in-the-blank type thing. You follow the instructions and you fill in the blanks, and then you leave these when you're done with lab, and we grade them and give them back to you at the next lab period. So if you don't have one, make sure you get to the bookstore and buy one before lab today. What time's lab today? 2:30. Okay, textbook. I didn't bring in my textbook. Anybody have a textbook? I'll show everybody this is our beautiful book. I usually hold it up so people know, oh, it's that one. Because sometimes people, get the wrong one. I started pulling out the planner. I was like, oh, that ain't it. Okay, so, yeah, I'll just go. Okay, look, there we go. There's what our textbook looks like. So if you have a different one, it actually would be kind of funny if somebody pulled out the wrong book. No, that ain't it. Okay, moving on. What are the objectives of the course? I'm like, why are you coming here? What am I hoping that you'll leave here with? Here's a list of things I hope to leave you leave here with. The most important thing to me for the entire class is that you understand what science is about. A lot of people take a class like this and they're going to be like a school teacher. How many people are education majors here? Okay. So once again, it's basically this side of the classroom. There are a few on this side that aren't. That's exactly what it was last year. Everybody on this side was education. Everyone over there was something else. But you're going to go be a teacher, and you're going to be teaching science class. You're going to have these little, kids, third graders, whatever, and you have to teach them science. And so you're all like, well, we're going to make a volcano. We're going to watch a plant grow, and we're going to see if we microwave the water if it makes the plant grow differently, whatever. I want to make sure that after taking this class, you understand what the essence of science is, so when you're doing those things with your students, you actually know what's the science part and what's not science part. Because oftentimes people just think, oh, volcano, I made a volcano. And that's science. So we will have two important questions on tests on the scientific method. On the first exam and then again on the final exam, you will have a question that asks you to give 4 basic steps of the scientific method. You'll find different numbers of steps depending on where you look. I have my steps, and so you'll have to list those 4 steps, and then I'll give you an observation, and I will have you then apply the steps, obviously not doing an actual experiment, but describing, to show that you not just know the words, but actually understand how the process works. Now, I'm going to come back to the scientific method later in today's lecture, so I will end the scientific lecture part of the objectives by saying the scientific method is what defines a science. A science is something that explores and tries to add to our knowledge by applying a systematic method that is the scientific method. So if things are applying the scientific method to expand knowledge, then they fit in the field of science. Now, you might know we have behavioral science and social science, and people over in a building like this, the natural sciences, we tend to say, they call themselves a science, but they're not really. And they say, yes, we're a science, because, if you heard the words I just said, they do their experiments following the scientific method. But those of us in natural science counter, yes, but there are way too many uncontrolled variables. You don't have enough information to actually be able to draw decent conclusions. And so that's why there's kind of a disagreement. They're using the scientific method, but we would say not using it carefully enough. But of course, there's no way to use it carefully enough when you're doing something like dealing with people. We're going to cut off everybody's head and see how long they live. We can't do that. So, no, really. So there's a limitation on how it can be applied. Something you're probably well aware of, smoking. Smoking cigarettes, health hazard, right? Because it has been shown to cause cancer in lab rats. We have correlation studies that people who smoke are more likely to get lung cancer, yes. What I was looking for was that we have correlative studies that say people who smoke are more likely to have lung cancer than people who don't, but they're not causal. We don't say, okay, here's a group of people, we're going to give you something that we think is fatal, and we're going to control everything about your life, and here's a group of people we're not going to give something fatal, and we're going to see, what happens to life. We can't do those kind of experiments because they're not ethical. We do them in rats because we apparently, our ethics, don't care about killing rats, giving them poison after all. We do give rat poison to some rats. And so we have experiments that show a causal effect between cigarette smoke and lung cancer in rats, but not in humans. We have correlative studies that show that humans that smoke are more likely to have lung cancer, but that's a much weaker testing. Okay, moving on. In science, a big part of it is being able to, once you have done your experiments, be able to interpret that data and draw conclusions. That's why I was just talking about things like, we have a correlative study. You didn't show that A caused B. You just showed that A and B come together. And if you look on the internet, you can find lots of graphs that show really silly things that we know should have no linkage that correlate. Correlation does not imply causation is a common term. So understanding how to draw conclusions and how to analyze data, critical thinking skills, things we're looking for. Now the next one, know the major subfields in physics. We'll talk about that today. That's basically to see the breadth of physics. Physics is covering physical science. It's everything that you can touch. So chemistry is a subfield of physics. That's how it started out. But they got so complicated that we physicists, as long before my time, said, you guys just go do your thing over there. But that's why we have people like Ken Osborne, a physical chemist. He studies in a very physics kind of way the stuff that stayed in chemistry. Be able to identify concepts affecting the system. As we go through the class, we're going to learn about different physics ideas. And then you're going to have test problems, and you're going to have to say, well, this is going on because of this. So you have to look at a situation like, person's in their car, and normally they can stop at the stop sign, but today they come to the stop sign, they do what they've always done, they press on the brake, and they just slide right through. And in physics class, you say, okay, so why did they slide through today? And everybody probably has a good answer. Why would they slide through today when they don't normally? Because of what? I so can't hear what you said. This is better than last year. I got an ear infection last year, and I just couldn't hear for the first month or so of the semester, so I didn't even ask questions because I wouldn't hear the answers. I hope you said snow. Okay, because there's snow out there, and snow has a lower coefficient of friction, which means there's less friction between the tires and the car, and thus the car slides through. And so it's thinking about those ideas and how they fit together to make something happen that we're looking for with those concepts. Then we have a part that, it is the hardest part for virtually everybody, being able to solve problems. I do want you to be able to sit down there and solve a problem. This is not a heavy math class, but there is math required. Right? It's not going to be a class where it's just ideas. You're going to have to do some math stuff. And the last one, understand how scientific knowledge benefits society. Oddly enough, just yesterday I was reading a web forum where it's ask any physics question you want. And one person was writing back to the host about, science doesn't do us any good. We'd be much better if we had no scientific knowledge and we just, plowed our fields, grew food however way we could, and people starved to death as, in nature. I tend to disagree. I tend to think that science is great. I love having, my iPhone so I can check my email messages, check in on Facebook all the time. Well, that takes a whole lot of scientific advances to be able to do that. Simple things like having a room that is comfortable where I'm sweating when it's cold outside and snowing. That's a good application of science, something I definitely appreciate. And so I'm hoping that by the end of this class, you'll have a much better understanding and appreciation for how science affects your life every day. By the way, if you have questions, I know there's very little questions when you're going over the syllabus, things like that. But if you do, feel free to just blurt them out. Classroom decorum. You know what I care about most in classroom decorum? Cell phone usage. It drives me crazy. It's like people just use them everywhere. You go to church and you'll see people checking Facebook in church and stuff. No sense of propriety. Well, in class, I'm supposed to be helping you learn, and you're supposed to be taking the active part of learning. And if you're distracted by using your cell phone, well, then you're taking away that learning aspect that's your part of the responsibility here. So please, just don't use your cell phones in class. Now, if you have, and this is a question that's on the quiz, and this answer isn't there, if there is like an emergency, your friend got in a car accident, you're waiting for an update, well, I would certainly understand, I have my phone here, I'm checking my message because I want to make sure my friend's okay. But not like, well, my mom called. We've got to have our daily chat, or, my friend said she had a test and she was really anxious, and, let's keep that to a minimum. So that's what I care about the most. Accommodations. If you have a learning difference, it's your responsibility to go to the Teaching Learning Center, where they will make sure you have proper documentation for your learning difference and that you get the accommodations appropriate for your learning difference. And I just basically do whatever they tell me to do. Academic integrity, or as we more colloquially call it, cheating. I think we all know the basic rule, don't cheat in school. But what is cheating is not something that's often defined very clearly. So I have here some definitions of what is and what isn't cheating. Let's say you have a subscription to Chegg, and you go there and you say, here's the solution to my homework problem, and you copy it in your homework. That's cheating, right? You didn't do that. You just copied it. If you are finished with your homework and your friend says, hey, can I see what you did on problem 3? And so you give them the paper and they just write it down. You both participated in academic dishonesty. Now, that situation could be honest as well if it goes this way. If your friend said, hey, were you able to get problem 3? And you say, yeah. And you explain it to them. You explain it to them, that's helping you because you have to understand it better when you explain it. And it's helping them. So working together on homework assignments is definitely taken as a positive. But just copying is dishonest because that's not your work, that's somebody else's. And of course, on exams, you don't get to discuss the exams with other people. Likewise with quizzes, I know that generally goes without saying. I had a problem first semester, so I added another thing here. During exams, you'll be leaving your notebooks and everything, including your cell phones, up here, not back there. I had a situation last semester where a student had a cell phone with them and pulled it out, and it's actually not the first time it's happened to me. So I put in here, if you are found to have a cell phone with you, whether it's on or off, used or unused, right? Because it's really hard to prove what you've done with it, you'll get a 0 on the test. Right? So it's a very simple rule. make sure that when it's test time, your cell phones are in the cubbies up here, not back with you where you're taking the test. I want to make sure it's clear because I hate giving zeros to anybody anytime. Any questions about that? Yeah.
If we take information from the book for our homework, is that considered?
No, that's fine. The book is a standard resource that's there to help you learn it, right? And you can go and find help for your problems. It's that you just copy it that is not honest, right? If you work with somebody, they say, well, here's my solution. I did this because of this and this because of this, and you understand it, and then you write your own solution, not just copying what they have. That's fine. And of course, that's fine in my world. Different teachers actually have some different definitions. Another reason why I'm going through definitions. Okay, grading. Here are the things that are going to go into your grade and what you need to get for A, B, C, D, just stay with A, B, C. First of all, 5% of your grade will be based on clicker participation. Now, how many people already own a clicker? That's, it's more than half. For this classroom, it's clicker channel 33. So, I have a piece of paper. It's supposed to be taped right here, but it's kind of small to read. That says 33. Here's the easy way to remember. This is room 133. And so the channel matches the room number. Okay, so you're graded on participation in clicker questions. You're not graded on if you were correct or if you were incorrect. You're graded on if you participated. So it's were you present and paying attention and trying. Now the way I use these clicker questions is a few different ways. One way is to ask you a question about a topic before we get started on it, to see what students know beforehand. Another way is after I finish talking about something, to ask a question about what I just finished saying, to make sure that people understood what I said. And on that second type, where I ask a question over something we've just covered, I might have students ask other students what they answered after they put in their answer, and then discuss it and do it again. So why do I do these clicker questions? Right? Everything in the class should have a pedagogical reason. It should be there for something that's going to help students learn, and hopefully something that's going to help us assess. Learning is more important than assessment, but how do you know they learned if you don't have assessment? Right? Education majors? So I ask the questions and have you answer with the clicker because it forces you to think about how you understand it and actually put down in something physical what you think the answer is. And then, right after that, you get what the answer was. If it was correct, that's a positive feedback letting you know, yeah, I understood that, at least somewhat. If it comes back that your answer is different, that gives you the immediate facing, oh, I must not have understood that. What did I misunderstand to help you learn? Right? So there's a reason for it. It's not just, hey, here's another thing I can make students pay. We went with this system because it was $35 per clicker when we went with the system. They doubled the price the next year. But we chose this one because it was the cheapest at the time. But we don't do it for the money. We do it for helping students learn. So that's 5% of your grade just for participating. 5% also for quizzes. We're going to have the first quiz in just a few moments. I actually printed twice as many copies as I need because of a printer problem. And the quiz is just going to be about the syllabus. This quiz will be, by the way, open notes. So you can just look in the syllabus to get the answers. I just want to make sure we have some reiteration of what's in the syllabus there. We'll have potential test questions every lecture where I give a meaningful lecture. We will not be having them today. But every lecture where I give a meaningful lecture, I'll give you a piece of paper, and I'll just give you a bunch of them, and you'll put them in your notebook or whatever. And each lecture, you'll write out a question. Those questions need to be multiple choice format, not true, false, not yes, no, not A or B, but multiple, questions that relate to what was specifically lectured on that day. They shouldn't come from the textbook. They should come from what was in the lecture that you think would be a good test question. Now keep in mind, test questions shouldn't be too hard that nobody can answer them. They shouldn't be so easy that every single person gets it right. So you're looking for a balance there. And your question will be graded on the originality, which is real simple. If 2 people have the same question, they lose a point on originality. If 3 people have the same question, they lose 2 points on originality. That's how the originality score. They'll be graded on the quality of the question and, oh boy, there's a third one. Can't remember what the third one is. But I will go through and grade, relevance, making sure it's on topic. So those questions will be graded, and half of your test, when you have tests, half of the questions will come from questions that you people gave on those potential test questions. The other half will come from ones the textbook suggests. Also, except for this quiz here, the quiz questions will be 100% questions that students provided for what they thought would be good test questions. So I'm using this to keep students engaged and thinking about what they're supposed to be learning, and then writing questions, hopefully on things they understand. It's always embarrassing. Sometimes students will miss their own questions. You know, I give a question that somebody asked on a quiz, and they give the wrong answer. I'm like, oh. That reminds me, one last thing. On the potential test questions, you don't have to have the right answer on your potential test question. It's based on the question, on your answer thereof on the potential test question. Okay, homework. There's homework due every Wednesday. It's listed in the schedule what problems are due, so you could start now and do all the homework for the semester if you wanted. The first homework assignment is already available on Moodle. The others are not. If you were to go to Moodle, you would see HW01, and then it has things like Q and E and SP. The Q stands for question. At the back of each chapter, there are 4 actually, types of questions, but only 3 that I utilize. There's questions, and so Q means question. There are exercises, so E means exercises. There are SP, some kind of problem. And then there's take home or something like that where you do an actual experiment. I don't do the ones that have the experiments. But as we'll see, we have questions from each. If you were to click on the link, it would list all the questions. So you can see all the questions. And then you can submit your homework on Moodle, or you can write it out and turn it in on paper. Now, if you turn it on paper, it needs to be turned in by 5 p.m. Now, of course, you're not going to bring it to this classroom by 5 p.m. because I won't be in this classroom. You bring it to my office by 5 p.m. If you're going to turn it in on Moodle, you have until 11:55 p.m. You might ask why 11:55 p.m. That's as close to midnight as I can get without it saying it's due on Thursday. So they're due Wednesday, and you have 2 different time limits or cutoffs depending on if you turn it on paper or turn it on Moodle. I don't care which one you do, but I have the different time cutoffs because if you turn like at 11 p.m. here, how would I know? Turning on Moodle, I know exactly when it's turned in. So you have the homework that's due every Wednesday, and then we have laboratory experiments. Since lab is 1/4 of the credit for this class, I make it 1/4 of the grade as well. So the lab will meet here at 2:30 for our first lab, and we'll have lab every week. Midterm exams, we'll have 2 midterm exams, and then 1 final exam. So each midterm exam is 15% of your grade. Final exam is worth 20%. Now, there are 2 things I didn't go over. The lecture assistants and the attendance. The lecture assistants, I do a lot of demonstrations in this class. And I think it's beneficial to a student to be part of doing the demonstration. So the lecture assistance is something you have to come before the lecture and say, okay, now how about, Wednesday? Is that a day that would work for me to do the lecture assistance? And I look and I say, yeah, we got a good demonstration for that day. Then we will spend like 15 to 20 minutes going over what you're going to do in lecture to do the demonstration. And then during class, you'll be doing that demonstration. And depending on the quality of your work, if it turns out you're like, oh, I don't remember how to do that, I don't remember how to do that, you're not going to get much. But if you do a good job, then you would get as much as 1% extra credit, which I know is huge extra credit. But that's what the lecture assistance is. You can only do that once. You can't say, I'm going to do it 40 times and then shoot for, 50% elsewhere in the class. Right, you can only do it once. The attendance is its own beast. It's, I think, humorous story as to why I take attendance. But I take attendance, and I generally don't believe in the concept of giving people points for effort. I believe in giving people points for demonstrating that they've learned something. But this is the one place where I give effort credit. The school allows you to have one excused absence per week that you have lecture, or per day in a week that you have lecture. Wow, if this is per week, it'd be 15 for everybody. Per day in a week you have lecture. So we have lecture 3 days a week. Hence, you're allowed 3 excused absences. So I keep record each day, and I mark down if you are here at the time the class starts, when the clock turns to 9:30, if you are here within 5 minutes, or if you arrive later than that, or if you leave early, or if you are using your cell phone all during class. And if you're on time and stay throughout the class, you get 3 points. If you are within the first 5 minutes of class and stay throughout the class, you get 2 points. And if you are here for less than that, you get 1 point. And since you get 3 excused absences, if you lose only 9 points, I count that as perfect attendance. And I give you a 2% bonus, which is in my opinion, enormously sized extra credit bonus. It basically moves you up half letter grade, like from a B to a B plus type thing. If you don't reach that perfect attendance mark, then it doesn't affect your grade unless you miss more than 2 weeks worth of class. And yeah, in a class last semester, I had 3 students who were in that category. That's not what I ever anticipated happening. So that is an extra credit thing there. The grades I do round, so while it says 93 here, 92.5 rounds up to 93. Of course, 92.4 doesn't round up to 93. Just make sure it's clear. Any questions about the grading there? I'm almost done with my very long introduction. Looking at the schedule. So this is the beginning of the schedule. And so here we have today, January 11. It's a Monday. We're looking at chapters 0 and chapter 1, sections 1 through 3. Why is that there? So you can look in the textbook before coming to class and quickly scan over, this is what we're going to be learning in class today. Then we have, the main topic is introduction. Over here in the last column, it says homework/laboratory. This time I actually paid attention, got this right. It's homework on Wednesdays, and it's laboratory on Mondays. So you can see we're going to be doing the measurements lab today. And on Wednesday, we have homework. The 01 is telling us it's homework assignment 1. And then Q1.7 means it's question chapter 1, number 7. I have a comma 12. The comma means stay with the question, stay with the chapter 1, but it's question 12 now instead of 7. And then SP, I can't remember what it is, something problems. Chapter 1, problem 1. So that's the assignment, and if you look in Moodle, if you click on that link, you'll see the questions written out. So if you're confused about which ones are these, you can always look there in Moodle. They're written out, and of course, anyone can copy and paste them into a document and work from there. So you can see what we're doing each day. You can see that I make these in color. They're printed out in black and white, so you don't have the benefit of green means no school, red means exam, and so on. So that's how you read the assignment schedule.
So the homework's due on Wednesday?
Yeah, homework due after 1 day of class, of which we spend more than half of it going over the syllabus. It's not going to be a very big assignment, is it? It wouldn't be possible to be a very big assignment because we'll have very little. And then you'll notice the second assignment is actually only 1 more day because next class period we're going to do a pretest, which also is a small amount of extra credit as well. What I'm going to do is I give you a pretest to measure what you knew coming into class, and then later I'll give you exactly the same test to measure your improvement. And so, yeah, it's a good observation because it seems kind of odd to have a test so early. Okay, Moodle. Moodle is tightly integrated with the course. On Moodle, you have announcements. I'll put things like, oh, in class I forgot to do this. You have the course documents and resources, things like, oh, let's say that you wanted to see the slides that I used in class. There will be a folder where they're available on Moodle. They're not there now because we don't have any yet. Likewise, let's say that you want to go back and hear what I said in class again. I record the sound with my slides and the annotations, so if you were to go and look at it, you'd say, okay, look, that's where he wrote Richard on the screen. You'd have the sound and the video the same. And I post those to YouTube. And so the link for where they're posted on YouTube is also there on Moodle, so you can go there and find the lectures. That's also, I think, beneficial. If you had to miss a class for some reason, I was sick, you can always still get the entire lecture. Assignments and solutions. Right now, the homework 01 is just showing the assignment. And then you can upload your assignment there, turn it in there. And then after I grade them, your graded solution will be there, your graded homework will be there, and I will change where it has the questions to having both the questions and the answers. So you'll be able to look at the solutions for the homework there on Moodle as well. And grades will be kept there. Anything that's graded will be on Moodle. So if you don't see a grade for something on Moodle, that means it's not graded. So you can always be as up to date as I am with your grades. Okay, then one last thing, FERPA and box numbers. Y'all have a sheet that's just a single page, starts at the top, I blank am a student attending Union College. Then you have a bunch of blah, 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 blah. You have two check boxes, authorization granted or authorization not granted. And then a little more, you print your name, put your signature, put your date and number. Now, what are these for? I can't just put papers in a box and tell you to pick them up because somebody could keep your score. So this is you giving me permission, if you check the box authorization granted, for me to return, I forgot to write, potential test questions and quizzes and homework you turned in on paper to the boxes that are just outside this door. If you check the box authorization not granted, then I'll keep them in my office and you'll just have to get them from me in my office. Tests will always not be put in the box. Tests I will always make sure I give to you individually, just because I put a higher level of concern about students' grades for tests than I do for things like, a quiz or the potential test questions. So, check the box that's appropriate. Make sure you write your name, sign your name, put the date, and if you check the box authorization granted, make sure you write down somewhere what this number is. Now, we'll put that number in the Moodle gradebook. It'll show up as an assignment you got an F in, but it won't be worth anything, so don't worry about it showing an F in it, right? You can't fail your box number. And it'll just be there so you can look at your grade on Moodle and it'll tell you what the box number is in case you forget it. Make sure you give these back to me before we leave today. And now, actually give them back to me with the quiz. Now it's time for our first quiz. So, like I said, I got enough of these for everyone to have two. And this is open book and open notes, so I'm not highly concerned about anything except for that you have a chance to show that you understand some of the basic policies of the class. And to get off with a good grade in class. You're going to do well on this. That does not go well. Everybody's done. So usually I'll actually put in a copy of the quiz and go over the questions more carefully. I will at least go through the answers here just to make sure we're all on the same page. Number 1, when is it acceptable to use a cell phone in class? Never. Thank you. Which is not an objective of this course? Yeah. To solve the mysteries of science. Now that is an objective of physics. But this course, we're introductory. We're not solving the mysteries of science. Number 4, when is homework due if you turn it in on paper? 5 p.m. on Wednesday. And when is it due if you turn it in on Moodle? 5 before midnight. Okay, so hopefully everybody got a perfect score on that. That's my goal. Any questions on the syllabus in the class before we delve into the scientific method?
We're giving you any materials for our lab?
No. All you need for the lab, I guess I should have noticed when you came in. We now have signs up telling students no food or drink in these rooms. So you're not supposed to bring food and drink. Make sure you bring that red book. That's all you need to bring. Well, bring a calculator. That's it. Any other questions? Yes.
I have a question. If you put your slides up on the
Yes. There will be a folder that has all of them, and then I'll upload them after we're done. I don't have that set up yet. Instead of going to the gym this morning, I got Moodle at least set up, so it's, that's where I am in my planning right now. Okay, scientific method. These are the 4 simple steps that I want you to regurgitate for me and then apply on both the first exam and the final exam. So these are the method through which scientific information is developed. So we start with observe something interesting. That is, you have to be curious in science. You don't just say, look, cold stuff fall from the sky. Right? You say, hey, I wonder why there's a water damage spot on that tile. Right? I observe something and I wonder why. Now, this is something that to me, when I'm out in public, can be problematic. Because you know how kids, they're so inquisitive. They're, why this? Why that? And you hear parents say, because. That's horrible. That's like killing the scientist in the kid. Because science is all about wondering why and trying to find out why. So that first step is to observe something interesting. The next step, develop a hypothesis that does these 3 things. Now first I have to make sure we understand what the word hypothesis means. A hypothesis is, I think our textbook says, a good definition is an educated guess. Right? So hypothesis doesn't mean, oh, here's the answer. Hypothesis means, this is what I think is the answer based on my knowledge. So it could be right, it could be wrong. But you've made a hypothesis an educated guess. That hypothesis needs to explain why the observation occurred. Right? It needs to be relevant in answering the question of why that science is dominated by. It needs to be based on scientific ideas. One of your homework problems is about astrology. Astrology is what we in physics, well in science in general, call a pseudoscience. It pretends to be a science. It goes through and does essentially the things you have here, except for one thing. The predictions made by your horoscope are not based on scientific ideas. They take scientific data, right? Your whole horoscope, you have your sign, right? I'm a Scorpio, which means that if the calendar hadn't been shifted by 11 days, the sun would have been in the area of the sky that is constellation Scorpius when I was born. Now, because the calendar was shifted 11 days, well, 10 days or 11 days, depending on what part of the country or not country, but the world, because they shifted at different times. It turns out that the sun was actually in Libra when I was born, but since astrology is not actually real and, that is, it's not truthful and honest, nobody really cares that technically I would be a Libra. And people who are into it say, well, yes, we just adjust the meanings of the horoscope to match the names being wrong. Okay, but that's what it means that I'm a Scorpio, that the sun was in this region of the sky when I was born. And the theory of astrology is that the position of the sun in the sky when you were born and other objects, and the position of the sun and the other objects in the sky now is going to affect your life. There's no scientific connection between the scientific data of where the sun and the other planets are and your life. That is just conjecture with no connection. That's why astrology fails as a science. Now, for that homework assignment, it says look up your horoscope. Actually, look it up. Write down the words. Right? My horoscope says, today you'll fall in love. Or, today, they're usually not even that specific. Today is a good day for friends. Yes. To have one, to have many, they make them very nebulous, so almost anybody's life will match up some way of interpreting the horoscope. So, back to this, getting back off of the homework. Your hypothesis needs to explain why the observation occurred. It needs to be based on scientific ideas, on knowledge that has already been developed through science, and it needs to make predictions that can be tested and falsified. So, now, astrology makes predictions. The problem is those predictions are so broad that they're really not falsifiable. But they need to make specific predictions. The next step, devise a test of your hypothesis. Now, this test of your hypothesis should not be a verification of your observation. Right? I see that there's a watermark in that tile. My test should be, so I'm going to look carefully and see if there's a watermark. Right? That wouldn't be testing any hypothesis. That would be just going back and saying, yeah, I'm going to double check my observation. So your test needs to be testing a prediction of your hypothesis. So I could, for instance, with this drip, say, okay, hypothesis. I know, I called it a drip because I was already going through what we see is just a discoloration. But I know that if I have water dripping on something, it can cause it to change. And so I hypothesized that that change was caused by water dripping on it, and there must be something that's dripping water on it. So there's my hypothesis. Now I need to test this. What are some ways I can test that hypothesis?
You know, exact another tile and drip water on it.
Okay.
It turned exactly like that.
That is one of the two things that I had in my mind. It was actually the one that I thought would be less likely to be answered. I could take another tile that's just the same. We want to make sure we control our parameters. Don't just get any old tile. And then drip water on it and see if it forms a stain that looks the same or if it looks completely different. Right? If it looks completely different, then I just disproved my hypothesis. But if it looks the same, I didn't prove my hypothesis right. I just said, well, yeah, that could be it. Okay, another test. What's another test I could do? Of the same hypothesis.
Go up in the roof and look.
Okay, well, I was thinking something on that order. I could take that tile out and put a cup under here and measure if there's water that hits the cup. So those are different tests, but they're tests of the hypothesis predictions, not tests of the initial observation to see if it was right. Yeah, we can see this color. So that's step 3. The final step is determine if the hypothesis passed the test. If it passed the test, so if the tile discolored, looking similar, if my beaker had some water in it over time, then I go back and I do another test of a different prediction. If it fails, on the other hand, if we had the discoloration on the tile was completely different when I did my experiment, well, then I proved that I was wrong. In science, you can prove a hypothesis wrong, but you can never prove it right. If you prove the hypothesis wrong, then you go back and you have more knowledge. You've learned more about what it isn't. And so you make a new hypothesis, incorporating your new knowledge, so that you hopefully have a new revised hypothesis that is more correct. So I started with my initial hypothesis, which was basically a blind guess based on my past experience. I did an experiment. If that experiment showed that my hypothesis was wrong, I now modify my hypothesis because I have more information. Why is this method so vital that it's going to be on your test 2 different times? By the way, your tests are going to be like 50 points, and this is going to be 8. So it's going to be a huge percentage of your test. Not just one question that's a small amount. My time's out. Why is this so important that I spend so much time on it? I'll give you the answer because we're out of time. It's because this is how we develop our information, our knowledge base of science. And so the process with the developing a new hypothesis, if you're wrong, helps us to narrow things down. So over time, if you follow this method, you should come closer and closer to a correct understanding. It doesn't always work that way. I gave you some examples, but that's the reason we use this. All right. Have yourselves a great morning. Remember, if you don't have one, to make sure you purchase one of these before lab time today. I'll see you here at 2:30.